Hey guys, so we're going to start out your volcanoes notes. Thus far, you guys have watched the Deadliest Volcanoes video, and you've also done your volcanoes worksheet and your volcanoes web quest. So hopefully a lot of this will sound familiar to you. All right. So first up, we're talking about magma and lava. We've talked about them a little bit before. Mainly the difference, of course, is that magma is below Earth's surface, lava has reached Earth's surface. And so the composition of that magma, or what's in the magma, is going to determine how violent of a volcanic eruption we're going to have. So we have a couple of rules here we need to remember. So the more viscous the magma is, the more violent the eruption is. So we remember from physical science that viscosity is how resistant a material is to flowing. So if it doesn't want to flow very well, and then all of a sudden it's being forced to flow, that's what's going to give us some violent volcanic eruptions. So what's going to affect the viscosity of our magma? Well, a few different factors. So the temperature of the magma, so we know that warmer materials will be less viscous. We also know that the gases that are in that magma have a big role to play. So we saw this in our Deadliest Volcanoes video, that the amount and then also the pressure that those gases are under will also cause a difference in our viscosity and therefore how violent the eruption is. And lastly, we're also concerned with the silica content. So we learned back when we learned about our minerals, about silicates. And so the more silicates we have, the more violent it will be. So less than 50% silica would give us basalt. So we learned about our basalts, our igneous rocks as well. And we know that less silica content will mean that it's less viscous and less violent. The more silica content we have, the more viscous it will be, and therefore the more violent that eruption will be. So we'll look at a couple of different types of lava flows, and we'll see how the viscosity of that lava makes a difference in what it looks like and how it behaves. So the reason that that silica content is so important is because we know from learning about silicates that they can form these chains or even sheets. So the more chains they have, then the more viscous it will be and the less likely it will be to flow. So more viscosity, more violent. So when our volcano does erupt, we've got several things that will be ejected from the volcano. So first we have lava, of course. So we have two distinct types of lava that we are going to need to know. So these are both Hawaiian terms. So the first one is pronounced pahoehoe, and that is when we have a low silica content. So it's going to give us these this really smooth lava that isn't very viscous. Like I said, it's going to flow really easily. So there's our pahoehoe flow. Again, it gives us like those wrinkles that we sometimes associate with lava. If that lava has a higher silica content, we call that flow ah flow. And so it has more silica in it, so it's not going to be nice and smooth. It's going to have these more so jagged edges to them. So when I was in college and I learned these terms, my geology professor taught me that to remember which one is more jagged or more rough, we think of it as of the flow as like if we were stepping on that one, especially if it had cooled down, right? Because it would have to have cooled. But then that would be rough. And if we were stepping on it, we would be like, ah. stepping on that. So hopefully that's an easy way for you to remember the difference between your two lava flows. Other things that are going to come out of the volcano are going to be some gases that were originally dissolved. And so we learned about that in our Deadliest Volcanoes video as well, these gases that can be dissolved under certain pressures. And so once they have erupted, just like shaking our bottle of pop, for example, that gas gets released. So that gas, those gases can be released with, again, the carbon dioxide, sulfur dioxide, and water vapor being the main ones. Other materials that get ejected are called pyroclastic materials. So this is any type of rock that gets ejected, and they're basically going to be based on how big of the pieces are that are being ejected from the volcano. So we have a slide specifically about those. So again, it's based on their size or their particle size. So the smallest we have is ash. So this is going to come from very small pieces of rock and glass created by our volcanic eruption. So we see a little pile of that here, and we saw it in our video as well. The next size up is lapilli. So we see that here again, these rock fragments. We don't have a picture for blocks, but that's just going to be bigger than lapilli. And then largest we have are bombs. So again, these are bigger pieces of lava that just harden as they travel through the air. So it depends on their size. These are all pyroclastic materials. So from our volcanoes, we can get some different land formations. One of them is a caldera, which we learned about in the section of our video about Italy, where we have this area where this was the summit of the volcano, but it has collapsed. So depending on its size, we either call it a caldera, or if it's small enough, we call it a collapsed pit, but that often will fill in with water, and then we end up having a lake. So again, you'll notice on this slide that for each one, I just had you reiterate, this is when it collapses, it collapses, it collapses. So there's several ways that our volcano can collapse, just depending on the type of volcano, and then of course, like whatever we have underneath the volcano that's helping to keep it up. So if that goes elsewhere after the eruption, then we will have a collapse. All right, some other land formations that we get from our volcanoes. So these are called volcanic fissures, which are going to happen along the flanks or the sides of a volcano, and they can release lava in large amounts, and it can just, you know, be more devastating because lava is not just coming out of the center and top of the volcano, but it can come out elsewhere. So those are our fissures. The volcanic pipe is just going to connect that magma chamber that's underneath the volcano to the surface, sometimes also called a conduit. And then our volcanic neck is going to be basically where we had magma in the volcanic pipe ready to go, ready to erupt, but it just didn't erupt. And if the rock that's around it ends up eroding away and the magma hardens, we're left with a volcanic neck. So we've got some pictures here. On the left, we've got Devil's Tower, that's in Wyoming. That's an example of a volcanic neck. And then in our volcano diagram, it's just kind of going over some of the things we've already discussed. So again, we've got our pipe or our conduit in the center there, pipe or conduit in the center. And then we've got some pyroclastic materials being released, some lava being released, and then of course some gases being released. So in our next video, we'll talk about some of these terms like a sill or a dike, and how those relate to our volcano as well.